Yes, hello. I go by the names of Mokonya Ata Ainsin, and I would like to take this opportunity to speak about drones. There are various questions that we'll be tackling in this video. For example, what is a drone? What is made of a drone? How does a drone work? We shall be tackling these questions in this video. Yes, what is a drone? A drone can be known as a UAV, standing for Unmanned Aerial Vehicle. It can also be known as a UAS, Unmanned Aerial System. A drone is autonomous and non-autonomous. What do I mean? With autonomous, a drone being autonomous, a drone can be flown using an automated pilot software like the DJI pilot, like Drone Deploy, in a way that you can set missions for this drone, send it to carry out these missions, and return back to you. Yes, with non-autonomous, this is when the drone is being commanded by a drone pilot manually on the ground using an RC. RC standing for a remote control, sending commands to the receiver. This receiver is inside the drone. This receiver is put on the FC. FC standing for the flight control, also known as the brain of the drone. Looking at the evolution of drones. With the evolution of drones, how do drones come about? Or when did drones come about? Drones were earlier seen in the early 1800s. This is when the drones happened to surface. Drones were seen in the World Wars, for example, the World War I and World War II, and the Vietnam War. Types of drones. We do have the single-rotor drones. We do have the multi-rotor drones. We do have the hybrid drones and the quadcopters, which of late they are the most common drones, most efficient drones, most stable drones. With examples of these drones having 4 motors, 4 propeller design. Examples, we do have the Phantom 4. We do have the Mavics, having the Mavic 2, the Mavic 3 Pro, and some other examples, the DJI Avatar. Yes. And another question will be, how does a drone work? I'll start by tackling what is made of this drone. What do you need to come up with a drone? Or what's inside a drone? A drone consists of an FC, known as the brain of the drone. A drone consists of a PDB, known as the power distribution board. A drone consists of the receiver that attains commands from the RC. RC, as I said earlier, this is a remote control. A drone consists of a camera. A drone also consists of a 14.8 volts battery. This is for these usual drones, because as drones are advancing and being given more tasks, the energy and the current consumption happens to differ. A drone consists of the VTX. VTX, this is the video transmitter. It transmits feed from the camera on the drone down to the controller that provides a display on the LCD that is connected to the controller. A drone also consists of sensors. Speaking of sensors, sensors are mainly tiny compared to the size of ants. With sensors, we do have the IMU, the initial measurement unit. With these sensors come with the use of the MEMS technology. With the MEMS technology, we do see that machines, tiny scale machines, having moving body parts inside them. This aligns with the MEMS technology. This IMU consists of various sensors. For example, we do have the magnetometer, we do have the accelerometer, and we also have the gyroscopic sensors. Looking at the PDB, the power distribution board, consists of pluses and minuses. A drone also consists of ESCs, standing for electronic speed controllers. Back to the PDB. PDB consists of pluses and minuses. A PDB, the work of a PDB, the power distribution board, is to distribute power all throughout the drone. On this PDB, it transmits power to the 4 speed controllers, the ESCs, electronic speed controllers of this drone, to the motors. It distributes power to the FC. This is the flight control, the brain of the drone. It distributes power to the VTX. It distributes power to the receiver. Let me say it distributes power to the entire drone. What's the work of the ESCs? ESCs regulate the speed, or they control the speed of these motors. Each motor is assigned a ESC, because when you are working with a drone, motors act differently compared to the other, as by the command sent from the RC to the receiver of this drone. Yes, those are the components that are found in a drone. Actually, for the case of the FC, the flight controller, if you distribute power to the FC, it must not go beyond 5 volts. Beyond 5 volts, you'll just fly the FC. So it must be supplied with 5 volts. And on the power distribution board consists of a slot that's having 5 volts, 12 volts. So make sure it is distributed with 5 volts. And another question will be, how does a drone work? How does a drone get to hover? How does a drone pitch forward? How does a drone pitch backward? How does a drone go up? And how does a drone move down? Yes, with me here, I'm having an example of a drone. This is a Mavic Pro. This is a Mavic Pro. As I said earlier, these drones are having 4 motors. 4 motors and 4 propellers. But these motors act differently. So these motors, they are having a set. Let me say this is our first set, the forward set and the behind set. What this motor does, it is not the same thing that this motor does. The functions are different. One motor will be rotating clockwise and another motor counterclockwise. So they rotate in different directions. Same thing happens to the behind motors. They all rotate in different directions. But diagonally, motors diagonally, they do the same thing. If this motor is rotating clockwise, that means this corresponding diagonal motor also rotates clockwise. If this motor rotates counterclockwise, that means this other motor that corresponds diagonally also rotates counterclockwise. How does a drone get to hover? The drone uses 2 forces. We do have the thrust force and we also do have the lift force. So for a drone to hover in space, it has to balance the weight. It has to balance the weight and has to balance the force. Meaning all these motors will be spinning with an equal force for it to hover. Meaning it will be cutting through As this propeller is rotating, or as all these propellers are rotating, they are going to be having the same force. Meaning all these propellers are cutting through the winds, making sure they are balancing the weight and force up and down, giving this drone the capability to hover in one position. That means they have balanced the weight and the thrust force. How does a drone pitch forward? Or what happens when a drone is pitching forward? In case I'm pitching this drone forward, there will be an interaction with these motors for that action to happen. If I want to pitch this drone forward, the force of these forward motors will lessen and the force will be different with the behind motors. That means the force on the behind motors will be spinning very fast compared to the motors in front, forcing it to create an angle. And as these motors behind are spinning very fast compared to the front motors, the force from the behind of this drone, or the force from the behind motors, will force this drone to move forward, to pitch forward, and vice versa. If I want to pitch backward, the motors on the drone will communicate in a way that it will create an angle, lessening the force and energy on these behind motors, giving more force and energy to the front motors. With the help of the ESCs, the electronic speed controls, that's how these motors tend to communicate, and the speed of the rotation changing through the control of the ESCs. So the force from the forward motors will increase and the behind motors will reduce on the force they are using, or the speed of rotation will reduce, forcing it to pitch backward or to move backward. What if I want this drone to stay in the same position and keep on rotating? That we call roll. If I want it to roll, what will happen, or what communication will these motors be sending to each other? So if I want this drone to rotate in one direction, in the same position, they will communicate diagonally, which was not for the case when I wanted to pitch forward or pitch backward. The front motors were communicating differently with the behind motors. But this time round, it will be working diagonally. These motors will be communicating diagonally. So what will happen? This motor, let me say I want to rotate this side. If I want this drone to rotate this way round. So these motors will spin faster and more energy will be applied to these motors. These motors will spin faster and more force will be applied on these motors compared to these other motors diagonally, giving it more force to rotate, vice versa the other way around as well. The communication is on the motors diagonally. What if I want to push this drone or command this drone to yaw? Or like if I want this drone to move to the left and I want this drone to move to the right, what will happen? communication is on the motors. If I want this drone to move right, that means the motors, if I want this drone to move this side, these motors will spin faster and more force will be applied on these motors. They will spin faster and more force will be applied to these motors compared to the force and also the speed of rotation of these motors will lessen, forcing the drone to move to my right, and vice versa. If I want the drone to move to my left, it's vice versa. These motors will reduce on the force of rotation, and these other motors will spin faster and more energy will be applied on these motors, forcing it to move to my left.